matrix multiplication. Let's get started. Let's take two 2x2 matrices, E, F, G, H, and A, B, C, D. How do we multiply them? We take the first row and multiply it with the first column. Similarly, we multiply the first row with the second column. And we repeat the same process for the second row. And our product becomes this, as shown here. But why does matrix multiplication work this way? Why is it not just A, E, F, B, G, C, H, D? And we'll be looking at it. To understand matrix multiplication, we need to understand what we call linear combination. Now let's take a point, P, x1, y1, and transform it to say x2, y2. How do we do that? There are numerous ways to transform a point to another point, but we'll be using linear combination to do it. So what's linear combination? Linear combination is just writing each coordinate of a point as a sum of the coordinates of another point that are multiplied by constants. Now this is a lot more confusing. Let's take an example to understand this. Let's say we're transforming the point 2, 5 to 7, 3. Now what our plan is, we are transforming this using linear combination. So our transform point is 7, 3, right? So we write x coordinate, we take x coordinate 7, and we multiply the coordinates of this point 2, 5 by constants and either add or subtract them to get 7. So how do we do that? We know that 2 plus 5 is 7. So 1 times 2 plus 1 times 5 is 7, where 1 and 1 are constants, and 2 and 5 are the coordinates of the point that we are transforming, and 7 represents the x coordinate of our transformed point. Similarly, for 3, how do we write 3 in terms of 2 and 5? It is just negative 1 times 2 plus 1 times 5, where negative 1 and 1 are constants. So let's use the same method now to transform x1, y1 to x2, y2. So we write x2 as a constant a times x1 plus b times y1, where a and b are constants. And we write y2 as another constant c times x1 plus another constant d times y1. We'll use the same method now to transform the point x2, y2 to x3, y3. Now why are we doing these transformations? I'll explain later. Hang on with me. So we repeat the same process. So we write x3 as a constant e times x2 plus f times y2. And we write y3 as g times x2 plus h times y2. Moving ahead. So the question is, how do we transform the point x1, y1 to x3, y3 directly? So the method would be linear combination. But let's use our previous equations to do so. So we have 4 equations, equation 1, 2, and 3, and 4. So what we do is we substitute the values of x2 and y2 from equation 1 and 2 to equation 3 and equation 4. What do we get? We get e times ax1 plus by1 plus f times cx1 plus dy1 equals x3, g times ax1 plus by1 plus h times cx1 plus dy1 equals y3. Simplifying these a bit, we get ae plus fc times x1 plus be plus fd times y1 equals x3, ag plus hc times x1 plus gb plus hd y1 equals y3. So this is pretty much straightforward. We've just done a bit of simplification. Moving ahead. Now, the way of this transforming a point becomes a lot more messier. If you see, when you're dealing with a large number of points and you just keep on making transformations, then dealing using linear equations like this becomes a bit more messier and a bit more confusing. And that is why we use matrices to make this much more useful. So we write these linear equations as in the form of matrices. So how do we write that? And that's a simpler way to write it. So let's take equation 1 and 2. So we write constant coefficients as one matrix, and we write the variables as another matrix, and our product is another matrix. That is A, B, C, D represent one matrix, and x1, y1 represent the other matrix, and our product is also a matrix. That is x2, y2 is another matrix. And you can see it here, that is the constant coefficients are a matrix, the variables represent one matrix, and the product is another matrix. Now we have devised a way to write two equations as in matrix form. So we need to follow the same rule for other equations as well. So how do we write it? So we write constant coefficients. So let's look equation 3 and 4. So we write E, F, G, H, and we multiply it with x2, y2 to get x3, y3. And you can see in equation 8 as shown. Similarly, we can look at equation 5 and equation 6. So AE plus FC, BE plus FD, AG plus HC, and GB plus HD is a constant matrix which represents the coefficients of the variables. And x1, y1 is another matrix, variable matrix, and our product is another matrix. So now let's combine equation 7 and equation 8. How do we do that? We just substitute the value of x2, y2, the matrix x2, y2, in equation 8. That is, we just put ABCD times x1, y1 in equation 8. And by combination it becomes EFGH ABCD times x1, y1 equals x3, y3. Now if you see these two equations, they're giving us the same product. That must mean that these two matrices, the multiplication of these two matrices must be equal. That is, AE plus FC, BE plus FD, AG plus HC, GB plus HD times x1, y1 must be equal to this. So, if you notice that x1, y1 is the same in both equations, that must mean that this constant coefficient matrix must be equal to the product of these two matrices. So at this point, it is reasonable to say that the multiplication of these two matrices must be this. But this is why we follow the rule of matrix multiplication the way we do it. Thank you for watching. Happy learning.